other astrophysicists and astrobiologists think about the search for extraterrestrial life? What do they think of Oumuamua? What about Three Eye Atlas? I'm Chris Daly, and I'm here with Ryan Geckner.
And what happened in Roswell, New Mexico last week? And we got a book contract. What will we be writing? This is Headlines from the Beyond.
All right, I love the fact that we're talking about our book contract, but we'll do that later.
Yes, we're going to make you listen to the whole episode before we get to that.
So we're going to start with just a quick update on Three Eye Atlas itself. You may have seen in the news that the first X-ray spectroscopy has been done on it. Now, X-rays are found in natural comets. So an X-ray, if you're thinking non-medically, we all know what a medical X-ray is, and they work using X-rays, obviously. But what does that mean? It's a high energy form of an electromagnetic radiation, so it's got short wavelength, high frequency. Comets emit these things, and they emit them really because they interact with fast-moving solar wind. And so the wind interacts with the comet's atmosphere or coma. So what's happening is there's really highly charged ions in the solar wind, and they collide with the neutral atoms and molecules from the comet, and they exchange electrons. So if you've taken, high school chemistry, you know about these things, the exchange of electrons. So electrons get excited, they release energy as X-rays, and this is called a charge exchange. And so this is happening coming off of Three Eye Atlas and other comets. So X-ray emission has not previously been seen in interstellar comets, but it has been seen in comets from our system. So that's interesting. This has now been seen in Three Eye Atlas, so now we can say it's in interstellar comets as well, if this is in fact a comet. It doesn't really tell us anything overly new about what Three Eye Atlas is, but it is an interesting piece of information. So that's the update on Three Eye Atlas, and hopefully we'll be getting some more interesting updates on that in the coming days, because we're getting pretty close to when it's going to be closest to Earth. So I'm sure we'll get better pictures at a minimum. So we thought it would be interesting to dive into a little bit about what mainstream astrobiologists and astrophysicists think about the search for extraterrestrial life. And so let's do a little bit of that. There are two main things that people are looking for, and that's either these technosignatures, like we've been talking about with Avi Loeb, or there's biosignatures. So the traditional SETI, which we've talked about before, search for extraterrestrial intelligence, they're looking for radio waves. And so they're using these large radio telescopes, and they scan for narrowband continuous radio signals that would be unlikely to occur naturally. So they're looking for sound that might be deliberately or accidentally emitted by some sort of advanced civilization out there. They also, and people don't talk about this as much, but there's also optical things that they're looking for. And so they look for sort of pulsed laser signals in the optical spectrum and things that don't look natural again. And they find a lot of natural stuff too, but that's what they're looking for. So the other sort of mainstream view is this focus on biosignatures. And that's what a lot of people do when they say that they're looking for extraterrestrial life. So since you hate some of these terms, why don't you talk a little bit about biosignatures?
I hate these terms.
Oh, primitive.
Oh, yeah. Okay. Yeah, I do hate that.
Yeah, I'm not fond of it either.
So essentially, what folks who are searching for biosignatures are looking for is either chemical or physical evidence of quote unquote primitive life. So we're talking about microbes, simple organisms, things like that. So one of the ways that they're trying to do this is really by analyzing the light signatures of distant stars passing through an exoplanet's atmosphere. And they're searching for, what would be called kind of molecular fingerprints or absorption lines that indicate biological activity. And so some of the molecules that they're looking for that are kind of the key ones, should probably be not super surprising to you, are oxygen, methane, water, carbon dioxide. The things that we know on this planet are necessary for life.
Right, so that's making an assumption.
It is.
That life requires those specific things because...
In all cases, ever.
Right, because in our system, it does. But as we start to see interstellar things coming through, we might learn other things. So that, I think, is just a flaw in methodology that does need to be pointed out.
Yeah, for sure. And they're also looking at things that are kind of exotic molecules like phosphine and dimethyl sulfide, which are difficult to produce naturally on a rocky planet. So think about planets in our solar system that don't have life, like Venus and Mars,
that we know
that
of.
we know of. That's true. That are, the stereotypical rocky looking planet floating out there in space. And this is all kind of based on the history of Earth and how evolution occurred on the planet. So we have primitive microbial life that's believed to be far more common and long-lived than, say, a technological civilization like ours, which...
Well, I think it definitely is.
Oh, yeah, for sure. Yeah. Which makes biosignatures a higher probability target. So if you're going to look out into space and try to find the possibility for life, you're more likely to find it from looking at these things rather than, say, trying to find any sort of craft floating through space.
Simply because it would be more common because they've existed longer.
Right.
So I understand why we would look for those things. And we actually have found on a variety of things that have come into our atmosphere, microbes and things that can survive and can survive from being in outer space.
And we've put a lot of stuff in space that has
we
survived.
Have. That's true. For long periods of time. So we know that these kinds of things can survive. So they're out there and they're searching for these. But all of this brings up what's often called the great debate. Is there life out there? Well, I think first off, I just want to say we know for sure that there is some life out there.
Yeah.
So really the debate is about what we call intelligent life. And we can talk a little bit about
the level of complexity of life.
Yeah,
I think is a better way to think about it. Yeah.
Because intelligence, it's a tough word. Yeah, well, IQ tests do suck. And it's just a tough word to use because how are we really defining it? Why are we saying that we're more intelligent than other life? Is there other intelligent life on our planet? And I would argue yes. So
look out, octopi. They're going to take over the world.
They might. So anyway, there's a couple of different ideas surrounding this that are pretty popular among people who study this. There are some people who are proponents of what's called ubiquitous life. And this makes some sense. So they're saying essentially Earth doesn't occupy a really unique position. The conditions for life, so having water, carbon, all of that, are pretty widespread. And we know this. So therefore, there's got to be life elsewhere because the conditions are right.
It's a big universe.
And so there's a guy by the name of Frank Drake. He's an astronomer. And I think I might have mentioned Drake's equation at some point. Maybe not. I don't know. But in 1961, he created the Drake equation. And this is essentially a probabilistic argument. And it's used to estimate the number of active communicative civilizations potentially in the Milky Way, which could yield a ton of numbers, really high numbers. The thing to remember about the Drake equation, before I even talk about what it is it's never going to be solved. And it's not designed to be solved. It's a conversation tool. It's a way to talk about the possibility for life being out there. So as I go through what these are, you're going to say, but we'll never know that. No, that's true. And Drake knew that. And everybody who uses Drake's equation and talks about it knows that. So it's not meant to be a solvable equation. So N, which is what we always talk about, is the number of civilizations in the Milky Way with which communication might be possible. So that's what you're trying to solve for. So the Drake equation basically multiplies out a bunch of other factors to get to N. So let's talk about what those factors are. And again, think about this more as a conversation starter. Don't actually try to multiply the numbers that don't exist. So first we look at the average rate of star formation in our galaxy, stars per year. We might actually be able to, figure something out.
We could probably guesstimate that.
Then we have the fraction of those stars that have planets, the average number of planets per star system that could potentially support life, the fraction of planets that develop intelligent life, the fraction of intelligent civilizations that develop technology to send detectable signals into space, and then the average length of time such a civilization releases those detectable signals in years. So you can see some of these things we might be able to estimate, we might learn, but some of them as I get towards the later ones, we just don't know. And so again, these are things to talk about. And so when you look at all of those things, that's a lot of unknowns.
Yeah, it is.
I took algebra and if you have more than one unknown in an equation, it makes it much more difficult to deal with. So that's a lot of unknowns and big unknowns.
Yep.
So proponents of ubiquitous life look at that and they say, look how much we don't know, but we do know that these conditions exist everywhere. So come on, there's got to be other intelligent life. We're not that special.
Right.
And I think that's actually a helpful view in general to look at. We're not that special. So then there's the skeptics, the rare Earth hypothesis. And I know you love the rare Earth hypothesis.
I love it. I love it.
So go ahead.
So this is essentially the skeptical view of extraterrestrial life, right? So the idea is that the evolution of complex multicellular life requires a host of such extremely fortuitous and rare factors, such as galactic habitable zone, a large guardian planet like Jupiter, plate tectonics, etc., that the possibility of other complex life in the universe is nearly, if not absolutely impossible. The conclusion here is that while basic microbial life may be common, so things that have come in off of meteors and things like that we can say exist, complex or intelligent life is exceedingly rare or possibly unique only to Earth. And so essentially you can boil these two approaches down to we're not special and we are special.
Right.
And
so pick how you like to talk about it.
Yeah, and I think for me, the reason I don't like this view, it's less because I disagree with it from like a sort of scientific perspective, even though I do, but more about like there are so many things to wonder about in the universe that why are you choosing to be like, nope, we have to be special and there's nothing else out there.
That's such arrogance, right?
Yeah, it is. It really is. It's like, embrace a little bit of mystery in your life a little bit.
And we've had these arrogances forever as we study humans and other things on this
everything.
Planet.
Yes, one step along the way, or at a step along every scientific process, we've had some sort of arrogant thought, and we stuck with it for a while, and then realized, oh well,
like we're the only ones with language,
right?
But we're not. Right. We're the only ones who use tools. We're not.
Yeah, right.
We're the only ones with culture.
Yeah. You're gonna get me to argue with you on that one, Chris. But still, right? There's a debate for that, and there are people there are lots of anthropologists who argue that we are not the only ones that have culture.
Yeah. That's how you define culture.
Yeah, and it's all in the definitions.
And our problem is we can't come up with one single definition. Right. So there we go.
Yeah, exactly.
All right, so those are two basic schools of thought. I love to talk about the Fermi Paradox, which is kind of another school of thought, and the way it's described is a question that Fermi proposed, and that is, where is everybody?
I love that.
Yeah. So first, let me just say a little bit about who Enrico Fermi was. He was an Italian physicist. He did, I believe, become a citizen in the US at some point in there. Yeah, because there was some strange political stuff happening in Italy, whatever. But yeah. So he is the architect of the nuclear age. He is the architect of the atomic bomb, and those are both terms that are used to describe him, the architect of these two things. He lived in the first half of the 20th century, and I bring this up because he actually died very young. So he lived from 1901 to 1954, so that's not a super long time. He died very young. He died from cancer, and I think it was a stomach cancer. But I do find it interesting that the architect of the nuclear age died of a cancer.
Sometimes the universe is kind of
Yeah.
Weird like that.
Yeah. So he created the first artificial nuclear reactor. He was a member of the Manhattan Project. So you've probably heard this guy's name, even if you don't know exactly who he was. Mm-hmm. But he won the 1938 Nobel Prize in Physics. And it was for his work on induced radioactivity by neutron bombardment and for the discovery of these transuranium elements. So all of this work that he was doing that led to the atomic bomb, gave him a Nobel Prize. He also made really significant contributions in statistical mechanics, quantum theory, nuclear physics, particle physics. I mean, this guy was a smart dude, made a lot of really big contributions. I don't think his whole purpose in life was to create something as destructive as the atomic bomb. Yeah. And most of those folks who were doing that work, that was not their sole purpose. Mm-hmm. It might have been why the government wanted them to do it.
Yeah, that's a whole nother conversation.
Yeah, that was not their purpose. Yeah. So when we look at this in terms of extraterrestrial life, what Fermi was looking at was saying, look, The universe is really old. The universe is really big. That suggests that advanced civilizations should have arisen. They should have colonized the galaxy. But this great paradox, we don't see any evidence of their presence.
Mm-hmm.
And so he just proposed this, well, where is everyone?
Mm-hmm.
This should be happening. He basically, is saying like ubiquitous life, that's a thing. It should be happening. So why don't we see people? So there are three possible solutions that have been proposed for this paradox. First is rare life, filters in the past. So the step from non-life to simple life, abiogenesis, or from simple to complex life, meaning the rise of like eukaryotes, is the great filter, which means we're really lucky to exist. So that kind of goes along with the idea, maybe we're special.
Mm-hmm. Mm-hmm. And the part, and I said that the skeptic approach is kind of off-putting to me. But if you know anything about the development of complex life forms on Earth, there are some sort of examples of serendipity in that process, right?
Yes, absolutely.
There are lots of things that kind of happened by what seems to be a little bit of an accident. So it doesn't seem impossible to say that.
Right. To say we were just lucky.
Right.
I mean, you can think about it too. Like, why were you personally born?
Right.
Because your parents happened to meet, but well, why were they born? And like, a lot of this is just kind of.
Yeah, you're like 2 degrees away from an existential crisis there, Kristen.
I'm sorry.
It's okay.
Anyway, so you can look at things that way. You can also look at short lifetimes for different civilizations.
Mm-hmm.
So technological civilizations inevitably, and I don't know if I agree with this, but I see why Fermi might think this.
Yeah.
Technological civilizations inevitably self-destruct. Nuclear war, climate collapse, all the bad things that are out there that we can talk about for days. Essentially, that makes these civilizations go away. So in the span of the universe, that means that the lifespan of these types of civilizations is pretty short. And I can totally get behind that if you think about how long we've actually been in existence compared to how long our planet has had life.
Exactly what I was going to suggest. Yeah.
Yeah. So it does make sense that maybe we don't see anybody because they've come and gone, because they are yet to come. I mean, or the ones that are closest enough to us have come and gone, or whatever it is. So that does kind of make some sense. Then there's the third proposed solution, which I find interesting personally. And that is that these other civilizations exist, but we don't see them. And so why might that happen? Well, one thing is the zoo hypothesis, and I love that term.
That is fun.
And that means aliens are intentionally avoiding contact. They're watching us. And I think that makes some sense.
Yeah, I can see it making sense.
Maybe, maybe not, but that they're out there and they're watching us, and so we're just kind of interesting to look at. Others say, well, they live in subsurface oceans. So maybe we don't see them because they're not living on land like we are, and that actually makes some sense because if you look at where the greatest biodiversity is, it's often in the water.
Yeah.
So that could make sense. Just because we developed on land doesn't mean other civilizations did. Or potentially they just use technologies we can't detect. Maybe in our arrogance in thinking that the way we developed things is right, maybe others just developed things differently and we're not looking properly. So those are all interesting, concepts of why we don't see anybody. So that's why I like talking about the Fermi hypothesis or paradox. Anyway. So those are just some mainstream views, and you can tell they're all different. But let's talk specifically for a moment about these interstellar objects. So we mentioned Oumuamua and what Avi Loeb thinks of Oumuamua. But there is a general consensus of others who say, well, we don't think that this was extraterrestrial. So Oumuamua was originally classified as a comet, then it was reclassified as an asteroid. And finally it's kind of, it's unique, it's different.
We don't know what it is.
We don't know what it is.
But we don't want to say that it's extraterrestrial.
Exactly. One of the big things that they talk about with Oumuamua was this non-gravitational acceleration. One of the things we're also talking about with 3I Atlas. So scientific consensus is saying, yeah, that's true. It was an anomaly, but we think there's natural explanations for this. And so, what could it be? Well, a variety of different things, but it's natural. So we mentioned Avi Loeb's idea of this solar sail. So other scientists are saying, well, look, it could be outgassing from hidden ices. We've talked about that with 3I Atlas too. So maybe these things are like buried in the surface, and when they erupt, it's shifting and whatever. But there's natural reasons why that could happen, is what they're saying. They also suggest that when you look at something that is very long and thin, that might not be technological. It might not be made by some civilization. It could just be something that we haven't seen before. It's just a shape that we haven't seen before. And I mean, I don't have a problem with thinking about those ideas, but I struggle with it sometimes when they're saying, well, if there's a possibility for it to be natural, then it must be.
Yeah.
And so that feels weird to me. So the data on these interstellar objects is really insufficient to rule out non-natural phenomena, and we do know that. But scientists typically just prefer to look at what's, I don't know if known is the right word, what is more common.
What's easy to classify.
What's easy, I like that. What's easy to classify.
We like to put things in the boxes that we already have.
Right. And that's what they're saying. Well, if there's a possibility it could fit in those boxes, then why are we even looking at something else?
And we shouldn't worry about the box that's in the room that we don't know exists yet.
Right. And I have a problem with that because it doesn't leave any possibility for something new to be discovered. And that's what Loeb is saying. And that's why I agree with him.
Yeah, and it's almost like you were saying, the mainstream scientific community is like, well, even if there's a possibility that it could be natural and there's a natural explanation, then it must be natural. Whereas Loeb is like, well, there's a possibility that it could be natural, but there are some things that suggest that it might be unnatural. So why don't we consider all of those possibilities rather than just automatically defaulting to, well, it must be natural.
Right. And so, to me, the broader view is better. The idea that let's look at every possible thing that this could be. Now, with that, the broader scientific community is not saying like we can't look for evidence of other life.
Just that you have to do it in a very particular way.
Yeah.
That there are these acceptable ways to think about it and talk and explore it. And as soon as you get outside of that, as soon as you get outside of looking for microbial life, looking for radio and laser signals in space, then you're way out on the fringe and we don't want anything to do with you.
And what's interesting about that is the things that are accepted are the things that would mean everything is safe.
Yeah, nothing would need to radically change.
Right.
About the way that we understand ourselves and our place in the universe. And I really think that's at the core of all of this, is this big ontological question of like, what does it mean for my understanding of reality?
Right, exactly. So what about 3I Atlas? What do mainstream scientists say? And we've mentioned this a little bit. Let's just kind of go through it.
Sticking to the same thing.
Yeah, so NASA and others are sort of saying, well, it's a comet. And that's what it is. Doesn't matter how strange it looks. There are possible natural explanations for everything that we've seen. No matter how remote all of those possibilities are for the different anomalies, they could all still be there. There is a statistical possibility that all of this is natural, even though the probabilities are very small. And so because of that, we have to say that it's natural. So as long as there's a statistical possibility that everything is natural, it must be natural. And incidentally, that is the same thing that mainstream science says about every single paranormal phenomenon out there.
Yep.
And that's where I have a problem.
That's where you lose us. That's where you lose me. Yep.
So that's our little deep dive on 3I Atlas for today. So what else is going on?
In other news, earlier this month, there was a fire at Roswell Air Center that erupted at Hangar 84. If you're at all familiar with the Roswell incident, you'll know that Hangar 84 is where they reportedly stored the recovered bodies and debris from the Roswell crash back in 1947. Interestingly enough, the cause of the fire still remains unknown, which has ignited some speculation about what may have been destroyed by the fire. Personally, I'm of the opinion that nothing was still at Roswell and hasn't been for a very long time,
Yeah,
but
that's probably true.
that doesn't mean that we won't talk about it a little bit on social media.
Yeah.
And our most exciting news update is that we have a contract to write a book on Morgellons. As you probably are not aware, Morgellons is our most popular episode by far.
Oh, by far.
I
Absolutely
mean,
by far.
almost 3 times the listens of many of our other well-performing episodes.
Right.
So thank you for all of the love on the Morgellons episode. In fact,
Absolutely.
if you search Morgellons right now on Spotify, our episode is the first thing that comes up, which is super exciting for us.
Cool. Yeah,
That's
we
very
enjoy
cool.
that.
And so we got a contract with Routledge, which is one of the biggest academic publishers, which is very exciting for us. They were super excited about the book as well.
Yeah.
So we will be doing a lot of writing because its anticipated release is in the spring of 2027. So stay tuned as we.
So for the next year, we're going to be doing a lot of writing on Morgellons, and we're going to provide some updates.
Yes.
Through the podcast on sort of what's going on with the Morgellons book, just so that everybody knows, because we've had, some great responses to it, and our participants have been fantastic, and we're excited to have them talk about it. If you're not familiar, this is about a research study that we did, and we talk about it on that episode.
Yeah. So if you haven't listened to that episode, please go increase the listener count on that episode and go check it out because people seem to like it.
That's our big news.
Yeah. So thank you for listening to yet another episode. We hope that you stay with us as we get closer and closer to 3i Atlas's nearest passage to Earth.
December 19th.
Yeah, and all of the newest things happening in the world of the paranormal. This has been Headlines from the Beyond.